For this week, we're going to talk about functions. Note, as far as homework this week, there is no homework, but we do have a quiz. So we'll do the quiz on Wednesday, and it's going to cover material from chapter 0 through the material that we cover here today. Open book, open note, you have an hour to complete it. So if you show up here on Wednesday, we'll take the quiz in class, and then you're free to leave as soon as you're done with it. All right. So functions. We've talked about some functions that are already built into Python, such as print, input, and the len function. The len function, does anybody remember what that does? Yeah, calculates the length of whatever you put inside there to calculate, typically the length of a string or something like that. A function inside Python is kind of like a little mini program within the overall program. So if we look at this code here, where we have def hello, and then we have print howdy, howdy, hello there. Then down below, we call that function. So we have hello in parentheses, and we're calling that function 3 times. We call it hello, hello, hello. Every time we call hello, it's going to print howdy, howdy, hello there. So this is pretty basic, but we would use it to run little mini programs within our main program, often used to calculate something or print something particularly that you're going to use over and over again. The idea being that if we didn't do that, we would have to print something like this across the screen. Notice this takes multiple lines in order to print this out, where we can reduce this down to a very small set of lines if we just do it this way. All right. The goal of the whole mini functions is to reduce the amount of code or reduce the amount of lines that you're doing and never having to duplicate code overall. So we call that deduplication, which will make your programs easier to read, a little bit faster and easier to update as well. So to create functions, we have to use a def statement, typically with parameters. So if we look at the example here, we're going to have def hello. Notice that name is inside of parentheses this time. When we print hello, then the variable name that we specified, we can use that inside our function however we want. When we call hello, we now have this required name input, which means we have to pass a name inside of it. If we don't pass a name, then the function will break and we'll get an error message. So if we pull this up here in idle, we create a function called hello, and we have to give it a name. Then we can say print, you gave the function the name of something like this. And then when we call that function of hello, we would just call hello in this fashion. If we try to run this, you'll notice that we get an error. And the reason we got an error is because it's missing the required positional argument of name. We said that we have to specify a name when we call this function. So we'll pass in some kind of name. And you'll get this kind of output outside of it. In a normal program, you would have something like my input equals something like that. And when we get that name in, we could go ahead and pass that into our function. So we could print my input there. So now we gather a name from the user. Let's try that again here. Okay. So we pass it in. We notice we get the name back of you gave the name of that, and the program ends. So if we were doing a main screen or something like that, that's why we would create a function if we're going to call that main screen multiple times. It's also a great way to organize your code as it gets longer and longer, kind of group little sections of it together and create a function for that. If we don't have a name requirement, then we would just pass something like that in, and then we would have to calculate it in here, or we would have to ask something like this. What is the name beforehand? And then we would have to pass in my input here. Now we could just call hello, and it would go ahead and gather that input inside the function and print out the same thing. Now, the difference is, and we'll talk about this in a little bit, is if I did this on the outside, I would be able to reuse that name, right? Because I specified my input out here in what's called the global space. When I do it inside a function, this is called local, which means I can only use these variables inside this local space. I can't use it on the outside. We're going to cover that in more detail here in a little bit. All right, when you define a function, you're going to use the def command, and then you can call it whatever you want. This has the same restrictions as a variable name, so you want to make sure that you start those with a lowercase letter. You can use camel case, etc. When we pass in a parameter such as this one here, we're passing in name, and then we can reuse that name out. We can also tell it specifically what we want. Now, right now, all we have in our little function here is to print something out. You also have the ability to return something back to the user. So instead of saying, what is your name, we can say, what is your age? And inside our hello statement, we would pass in an age. Return age plus 5. So there's a couple things going on with this function I created. One, we're getting this my input here. We're going to run this. It's going to ask for an age. And one, we're going to get concatenate that we're getting an integer in. We can only concatenate it if we're doing that, right? So we need to take int in order to get this in. Here, we got to convert it to an integer in order for us to add 5 to it. So again, a couple things going on. One, I'm asking for a variable called my input. I'm passing that variable into the hello function. The moment it comes into the hello function, it is now defined as age. Note that I am not using my input inside my function. So when I call this up here, from now on, whatever I passed in is defined as the variable age. You do not have to use the same name coming into these. So once I defined it as age, then when I manipulate it inside of here, I can say you gave the function the, let's change this to age of whatever. This is going to be a string. And then we need to convert it to an integer and add 5 to it. We're going to return that back to the main screen. Now, right now, nothing happens. So if we run this, we get an age of 32. We tell it that we return or gave the function the age of 32, but nothing happens with this integer plus 5. So what we could do is we could throw this in a print statement, and we would put print hello my input. So now we're calling a function from within a function. And then we would print that variable out. So if I run this now, notice how I get 37 that comes out here. That's coming from this input. You could also store that as a new one. So we could say new age equals, and we could run the hello function with the input that we passed in, at which point we could print new age out. And we would see the same thing, but that allows our function to calculate something and then return us a value back. You do not have to return a value. It could just be a simple series of print statements. You could be saving something out to the screen, etc. But functions have the ability to return a value if you want to. It doesn't have to be a number. It could return a string, and then you could use that string to print back out here in your main program if you wanted to as well.
Would we do that with the return itself, or would we just do a print statement?
In the return statement, you would return something like a string. So instead of printing this out to the screen, we could just do a return like this. And then in this hello down below, we would have to make sure we print that specifically. So if we print, it will go ahead and reprint that string that we just passed it. So I put in 32 and notice that this is what gets returned back out of this function. Therefore, we can print it out in our main program.
The niceness of Python.
All right. So if we look at this little function or program that they called here, it's basically a magic 8-ball, simple little game. All you're going to do is import the random module. We're going to create a function of get answer. We're going to pass in the answer number. And if the answer number is equal to 1, then return it's certain, 2 this way, 3 this way. Note that down here, we go r equals random.int, which means we're going to create a random integer between what? 1 and 9. Does that include 9?
Isn't that 1 and 8?
So does it include 9 or not include 9? It includes
doesn't
9, right?
Oh,
Yep. With the random int, you're going at the start and include the last number. Range is where it goes up to, but does not include when you're using the range command. It's the reason I keep asking those questions is students will often get confused between range and randint. So, okay. Once we get this random number, we're going to pass that random number into our get answer function, which will return to a variable called fortune, and then we print that fortune out. And in this case, it depends on whatever that random number came back as to what we will return back out of our main function. Does anybody have any questions as to how this code's working? Now, if we took something like this code here, it's going to be a little messy when I copy it in here, but second here, all the spacing's off a little bit. All right, let's see if it runs as we anticipated it would. We get back, it is certain, which means what did the random number that we get come back as? 1, right? So if we wanted to play this over and over, we could throw this into a while true loop, which we learned last week. And it's going to create a different random number every single time. Then it's going to go get an answer and print that out. And of course, it's going to do it indefinitely because we put it inside of a while true. So this would be the reason to use a function is instead of having this repeat itself over and over and over in our program, we can make that go through here and create this. So we could say random number, random dot rand int 1 to 10. Then we can say while, better yet, for I in random number, in this case, for I in range of 1 to random number. So now that I change this code, what's it going to do? This is going to what?
It should just print out a random amount of things.
Well, just this particular line, what are we going to have? What's happening?
Just makes a random number between 1 and 10.
Yeah.
Correct. So we're going to get a random number between 1 and 10. We're going to assign it to the variable of random number. In this line, we're going to say for I in range of 1 to random number, which means we now have a range of what?
From 1 to 1 less than whatever number was picked before.
Correct. So whatever this random number that came back as, we're going to have a range of 1 minus whatever that random number is, because we're going to go up to this random number, but not include it. And we're going to loop through however many times that is. For each one of those, we're going to create another random number. We're going to pass that to our get answer function, and we're going to print that out. So if we run this, in this case, what was our first random number? What was it?
9.
So we have one person saying 9 and we have one person saying 2.
Was it 10?
We have a 10.
Because if it's 1 less than the random number, then it would be 10.
You got it. So in order for us to get 9 lines out here, that means that this random number had to have been 10, because then we would have 1, 10, which would give us a range of 1 through 10, which would be 9 outputs. Then this random number, the first time around, was what?
2.
2, and then we go all the way through it, right? 2, 5, 7, etc. as we go and look those up. Does everybody kind of see how this little function works? I know it's super simple, but there's a lot going on there. Okay. In Python, we also have another value. So we've talked about several different values. We have what's called a none value, which is just the absence of a value as a whole. This would be a none type data type. So other data types we've talked about were integers, strings, floats, Booleans, true, false. We now have a none type variable, which is just the word none. In other languages, this might be something like null or nil or undefined. It must start with a capital N for the word none, and you can print that out. So if you try to do something like this, spam equals print hello, it prints out hello. None equals spam, that would be true, because there's no output of actual this phrase here. So behind the scenes, it's just going to return none out of it, which is simply like having a while loop or a for loop that implicitly has a continue statement at the end. It's not too often that we use the none value here, but it is useful if you need to set it to a blank value to start with. A lot of times people will just set it to an empty string, not necessarily a none value. And unlike C programming languages, you don't need to define it before you use it. Or the type, you don't have to define the type of variable before you use it, I should say. All right, so we talked about different keywords. When we use things like random int, and we go back to our code here, when we use this one, there's 2 variables that we had to pass in, right? We have to pass in a start and we have to pass in an end. If you created one or use one from what's built in, you'll notice that the moment I push the first parenthesis, we're going to see that we need A and we need B. And it's going to return that random integer in the range of A to B, including both endpoints. If I don't pass in anything, the program's going to crash because it needs those two requirements. Just like our get answer up here has one required statement or argument that you have to pass in. All right. Let's see here. A couple other things. When you're using the print statement. So for example, we have this print fortune. There is a keyword that we can enter in called end, and we can tell it what we want this print statement to end with. So by default, it ends with a new line character, which means it prints a new one on every single line, just like we've seen over here. However, if we tell it to print with a space, then when we run this program, you're going to see it puts it all in one line with a space in between those. We tell it to do a /t, that will put a tab in between every single one of those fortunes that gets returned, just like that. So in this case, we had what? 4 is our first random number, right? Then each one of those random numbers got printed. The statement was done with a tab in between each one. So this is handy if you need it to join a bunch of things together on a simple line. You can change what the print function ends with. Again, by default, it goes with the /n for a new line, which is why some of you will want a new line in between stuff. You just print this function here. By default, end is already specified as this within the main function. It's not required that you specify what you want it to end with, which is what makes it a keyword. We have to use the keyword end and then specify if we want to change it. So for our functions that we've already had here, for example, this get number up here, we could spec this as set number equals 10. If I run this, let's take this back and go back to normal. Note that the program runs just fine. And notice when I called get answer here, I did not use the set number. If I want to change that, I would say comma set number is equal to 5. Now I run it again, nothing's going to happen because we're not using the variable set number inside of our function. But this is specified by default and I can change it if I want to. This can be useful if you have some set parameters that you want to use by default. But if you want the user to have an option to change it, you can do that. Similar to the print, and we use the end in order to change what it ends with.
I have a question.
Everybody,
about that.
What's that?
I have a question about it. If you can go back.
Yeah.
So do you have to say set number equals 5, or could you just pass in 5 and it'll put it into set number?
So if I don't use set number, it assumes I'm passing into variables that will come inside there. It will put it in this placeholder here. So because set number is defined after answer number, it will assume I meant for set number. However, if I had another variable here called my number equals 4, then if I do 5, set number is going to be equal to 5. My number is going to still be equal to 4. So there's a positional argument as it goes through, as well as using a keyword to change it.
Okay.
I was wondering if it was like that for like the other coding languages where you can have like 3 different types of functions, but one that has 1, 2, and 3 arguments.
You could, yeah. Yeah, so this is positional as it comes in. Because this doesn't have an equal to something, this is a required parameter. These two are optional parameters, but they are positional. So if I pass in a 5 and a 3, then 5 will get assigned to set number, 3 will get assigned to my number. I can also specify specifically if I just want to change my number, then I will have to specify that and leave off the 3.
That works.
You would have to, right? you can set the keyword for this so that you can change this number here without changing the set number. But if you just passed in 5, it's going to change set number to 5, not my number to 5.
Python is, I didn't realize how really versatile Python was when it came to functions.
Yep. And this is something you'll need to know for the midterm exam. We'll cover this more when we get to the PowerPoints, but you have positional arguments, you have keyword arguments, and you have required arguments up here. You must specify all the required ones before you specify any keyword ones. Now, when Python works, it goes through a call stack, which just means that something's going to get called before the other one. So if you call functions from within functions, for example, we defined another function here, def get random number, random So we have this function here. Instead of this statement, I could just say use get random number. And inside here where we have a particular random int here as well, we can replace this one with get random number. And if I wanted to print at the end of my function up here, I could also call get random number. What's that? Yeah. Good call. All right, so when this program runs, the first thing that happens is it's going to run this here, which is going to call this function, return a value, return it back to random number. Then we go to this line. The first time it runs, we're going to call R with the random number, which means it's going to come back here, get a random number. Then we're going to call get answer with whatever random number we passed in. But also inside that function at the very end, it's going to call back to this function, return a variable back here. In this case, it does nothing. And then since after that first one's done, this whole thing comes back to this loop. Then it comes back and calls this one, which then calls this one, and all the way through. So you're going to be calling functions within functions. When you start nesting function calls within functions, it gets pretty hairy pretty quickly, meaning that I wouldn't want to call another function unless that function is very small and very written. So a lot of times people will have like, say a start menu or a main menu, right? You press 1 to start your program. If that doesn't work, they call start back all over again, which prints a whole menu. You don't want to do that. You want to stay in a while loop. Just make sure you're not calling functions within functions, especially if there is a lot of things going on in that sub function. In this case, we're just returning this random integer. So that's not a big deal. We're just always returning a random number. But if I was having you gather input, type a bunch of stuff in, printing a bunch of stuff to the screen, that can start to get a little hairy and you can get stuck into loops that still have a lot of code to execute yet.
We're going to talk about recursions, aren't we?
We're going to talk about what?
Recursion.
A little bit. Yeah. Yeah. All right. So we've talked about the call stacks as we go through. I talked a little bit about global scope and local scope. So inside of a function, we have a local variable here called answer number because we specified that here inside of our function. An answer number is known as the local scope with the local variable, which means out here in my main function, I cannot print answer number on the outside here. Because answer number, that variable only exists inside my function. So I will get back a not defined. This random number, however, is a global variable because it's in the outside of my main program. And so because it's a global variable, I can call it inside my function if I want to. So if I'm inside here and I say print random number, Notice how it printed 9 because this was the random number that we originally got from this function in the beginning. And it's going to print it every single time. So I can reference a global variable inside of a function, but I cannot reference a local variable inside the global space. Everybody see the difference between that? Now, if I say random number equals 10, and down here, I tell it to print random number, notice when I tell it to print the random number, the first time it calls 10, then it gets whatever random number that was printed out down here. Does everybody see what happened there? Those are two separate variables. I now have random number as a local variable, which is equal to 10, but my global variable is still set to 5. It does not overwrite the global variable. If you want to manipulate the global variable on the outside, you have to use the global keyword. So global random number. Now, if I say random number equals 10 and then print that, notice when I call it this time, it's always going to come up as 10 because we adjusted the outside number to be 10. So that anytime it's called from the global space now, we're going to get back 10. In order for this to be pulled off, I have to specify global and I have to tell it what variable I want to set.
Can you set that all on one line? The
What do you mean?
global random number then equal 10?
No. You want to use global random number, which tells this function we are using random number from the outside, the global space. Then we can go ahead and manipulate that number however we see fit. This is important because this is a question that everybody misses on the midterm because they don't pay attention. If I give you a variable called random number, how do I modify it in the global space? I must specify global random number. If I just put global, or if I answered the question with global, it would be wrong. Nothing would actually happen. If I just put global in here, the program crashes because it's invalid syntax. You must specify what global variable you want to do. Yeah.
Is it possible to switch it back to just in the block? Like you always specify global there, and then like after a little bit, I want to just modify in the function. Like private, so it's back.
You can create one there, but as soon as I say global random number, then the random number variable name, as long as it gets used in this function, is going to be that global random number there, or the global variable from the outside. Okay, so all of this last section is just repeating what I already said. Local variables cannot be used in the global scape. Local scopes cannot use variables in other scopes, meaning that when I set something like random number here, and I take out my global version, this random number here is 10. This random number here is whatever this random number comes back as. This random number down here is completely different as well. These are all three different variables in my program. This one's associated with get answer. This one's associated with get random number. This one's a global variable. I cannot call random number here and expect to get the number out of this, just like this one here does not equal this one here. I can't reference between functions unless it's a global variable. So if you need the variable available in more than one function, you want to specify it in the global scape, then you want to go and specify your global statements on the inside if you intend to manipulate them. If you're just calling them to print them out or something like that, you do not need to specify the global variable. However, if you specify something with the same name inside your function, it will default to the local variable, not the global variable.
So if we want to change the global variable at all inside functions, we have to do
Must
the
specify
global.
global. Yep.
Okay.
If you can read it all you want, but you can't change it unless you specify global. The moment you try to assign it with the equal sign or something like that, it becomes a local variable then.
Gotcha.
All right. So again, all of this is basically just explaining what I did on the screen. Okay. Couple things that you guys have done so far. When we have errors in here, you're going to get things like, oh, let's see if I can mess this up. Okay. When I get errors, I get a specific type of error. In this case, this is a type error because a non-type object cannot be interpreted as an integer. When I typed in ASDF here, this isn't actually anything. Therefore, I get a type error. When you try different things, you can get specific error types back. I have type error here. If I have something like and I run this, I get a name error, meaning that ASDF is not defined. I can always try to do what's called try and accepts. So in this case, I could try to do this. And if I get an exception on name error, then I can say print I can also just have a global accept issue that says print and what this will do is it will try to run the code up here at the top. If there's any kind of issues, it will find the first one that you define that matches that. So in this case, because we accepted on a name error, we get this print statement, which could be a whole lot more meaningful than something like this one up here where it says it's not defined. Particularly trying to divide, say, a string by a number or something like that, you get base 10 int. It's kind of cryptic. It doesn't quite make sense. You can specify your own error message that will come back to the end user. That way they are not getting this crash screen coming back. If we give them something that's not necessarily a name error, but something else, so if I print something like this, note that it actually executes and tries to do 0 divided by 5 and prints it out. There was no issue with what this was in here. However, if I have a string and try to do this, note that we get this is a different type of error because this is not a name error. It's another type of error. In this case, it's a base 10 error. We can check that by just removing this, do a run, and we'll see that we get a type error because we cannot do a division for a string and an integer.
Can you use
All right.
accepts without try?
No. Has to be a try and accept. And you
Okay.
must specify at least one accept. So why is this important? All right, up to this point, you guys have not been able to justify somebody typing in an age or something, right? So the first assignment, we had something like my age equals input. We had a print statement before that that says, what is your age? They type something in. And we have no way of checking whether or not they typed in a name or a number or a letter, whatever. We type it in here, it just takes it. So now we can do this inside of a while loop. And you want to make sure you put your question inside the while loop. we ask for this in here. We can say try to convert my age equals int my age. And if that works, then go ahead and do some kind of math. We can say my new age equals my age plus 10. On an accept, we can print to the user that is not a valid number. Please try again. And once this is done up here, because we're in a while loop, what is the keyword that we could use to get out of a while loop? Break. Gotcha. Okay, so we run this little program. If I type in letters, it's going to keep erroring out until I type in a number. If I type in 33 or 333, it's going to take it. So now we get into sanitizing questions and sanitizing input from the user, which means after this homework assignment 2, starting with homework assignment 3 and on your midterm, all inputs must be sanitized, meaning that if you ask me for a number, you should only accept a number. And you can do that by using a try and accept statement inside of a while true.
Is there an easier way of doing this?
This is the best way to do this. There will be easier ways to check whether it's a number and some other things here in a little bit. But right now, we're just using simple try and accepts to make sure that we are able to do this integer thing. Because remember, if I typed in input here or int over my input, and I typed in garbage, the program's going to crash, right? Now we get a value error, the program just crashes. This cleans up the input so that your program doesn't crash, and we only get the answer that we want. Now, the other part of this is if we get this my age, right? We could also do a check to make sure that it's a valid age. So if int my age is less than 0, we can say print that is not a valid age. Elif int my age is greater than 100 and say 20. We can keep doing this, and so it will check. And the only way they're going to break is if it doesn't meet those two stipulations. So now we're checking to make sure that they have to be less than 0 and then greater than 120. Yes, I could do something like this, and int my age is greater than 120. Or I could use the or statement, right? Or would be better there, not and. So now we're checking to make sure that they're not less than 0 and they're not more than 120. The difference between doing this and what I have in different lines is we can give different error messages based on what it actually is. So if we break that up into 2 separate lines, we can say that's not a valid age. You can't be less than 0. And in this one, we can say that they're not necessarily older than 120. So if we come in here and we type in garbage, it says it's not a valid number. If I type in 1,000 or 10,000, it says, I don't think you're really that old. If I type in negative numbers, it says that's not a valid age. You can't be less than 0. So in all of your work now, you want to make sure that whatever user is typing in, you can check and make sure that that's valid. There's easier ways to do validity for certain things, and we're going to learn that. But for now, you could at least check any age, ints, numbers, whatever you want. Okay. You can do division errors. You can accept on anything that you want to accept on.
Is there a way to do like I guess something dealing with global so that whenever an error happens where it's looking for an integer, but it's not integer, it just does it wherever you need it to. So like a global accept.
You would have to run your whole program inside of a try.
Okay, I was just curious.
Yep. And there may be reasons to do that. We will also use try and accept later on when we do imports, especially when we deal with third-party packages. We would try to wrap this in a try and accept. So try to import random. And if that doesn't work, we could specifically say print random module not available. Print program will now exit. And then we would use a sys.exit to end the program right away. In order to use that, we would have to import sys. Now, in this case, it's a little redundant because if the random module is missing, there's a bigger issue with Python, right? That's a built-in module. It should be there. But when we start dealing with third-party packages later, you want to wrap those always in a try and accept so that we can find out if that module is not installed. Instead of getting the red error message, which I should never see in your programs, I should get some kind of user feedback as opposed to just crashing. Again, if your assignments crash from starting here on out for your midterm, homework 3, etc., you will lose points on that part. You should sanitize your inputs as you're working on them. Anybody have any questions on that? Okay. In a nutshell, that's functions. We'll use a whole lot more functions as we start going through. But this is the basics of creating functions. Again, the goal is as you guys start writing your code, say for your midterm, you start working on it, right? You notice that you have a bunch of repeated code over and over and over again. That would be a good place for you to use a function. See if you can condense everything down to a function so that you can call that one function over and over. That's fine, but it's probably going to save you multiple lines of code. And I encourage you to write it in that fashion. Work on it by writing it with 100 lines of code, then start going back and looking at where you have a bunch of repeat code, see if you can write a function to condense that, and then further condense that. If your program is really long, like your midterms can be, use functions to break that up into logical groupings. So if I have a main menu and I say press 1 for this, then anything that happens for option number 1 on that menu should be in its own function. If option 2, it should be its own function. 3, it should be its own function. Anybody have any questions on those? All right. Again, on Thursday, we're going to have the quiz. It will cover everything from the beginning of this semester till now. Does anybody have any questions on quizzes? Again, open book, open note. You have 1 hour to complete it. Once you start, you have to complete it. You can take it in class here on Thursday. That's what I recommend for you guys that are in class here. Anything that's on a quiz, like I mentioned in the very beginning, look for bold and underline things or italicized things. I'm doing that for a reason.
I do have a
Alright.
question about I'm gonna guess we can't